Greetings from the Indian Community School, Kuwait. Dilute your worries, evaporate your tensions, and let us revise the main topics for your upcoming CBSE chemistry exams. Our chemistry question paper, there are 33 questions. Section A, we have 16 multiple choice questions of 1 mark each. Section B, 5 short answer questions of 2 mark each. Section C, we have 7 3-marker questions. Section D, we have 2 case-based questions of 4 mark each. Section E, we have 3 long answer questions of 5 mark each. The time allotment, you can see it on the slide. We have total of 10 topics, with physical chemistry coming for 23 marks, inorganic chemistry for 14 marks, and volume 2, which is organic chemistry, for 33 marks. Let us start from chapter number 1. Solutions. They are homogeneous mixtures of 2 or more components. We have 3 main types of solution depending on the solvent which we are taking. Henry's law, the partial pressure of the gas in vapor phase is directly proportional to the mole fraction of the gas. Its applications are important. Carbon dioxide is filled under pressure. It explains the biological phenomena of bends and anoxia. Raoult's law, we have under 2 conditions: for non-volatile solid in liquid and for solution of 2 volatile liquid. Do learn the graph with it. Again, solutions, we can classify it as ideal and non-ideal solution. Non-ideal solutions show positive deviation. In this, the AB interactions are weaker than AA and B and B. The vapor pressures are higher than that of the Raoult's law. Negative deviations, in this, the AB interactions are stronger than AA and BB. The vapor pressures are lower than as in the case of Raoult's law. We have 4 colligative properties, the properties which depend on the number of solute particles, not on the nature of the solute particles. 4 colligative property, the first one is relative lowering of vapor pressure. There is lowering of vapor pressure because of the solute particles which prevent the escaping tendency of the solvent molecules. Elevation in boiling point, as the vapor pressure of the solution is lower, it will reach the atmospheric pressure at a higher temperature, so that causes an elevation in boiling point. Depression in freezing point. Freezing point is the temperature at which the solid and the liquid phase is at equilibrium. The diagram, the graph is important, and the formulas. Osmosis and osmotic pressure is the 4th colligative property. Osmosis is the movement of the solvent particle from its higher concentration to the lower concentration. Osmotic pressure, denoted by pi, it is equal to CRT. If a pressure greater than osmotic pressure is applied, reverse osmosis will take place, and it is used for desalination of seawater. Osmotic pressure is a useful property to measure the molecular mass as it is working at room temperature. Depending on the osmotic pressure, we have 3 types of solution: isotonic solution, hypotonic, and hypertonic solution. A cell placed in hypotonic solution swells up, while in a hypertonic solution, it shrinks and shrivels. Do learn the applications of osmosis. Abnormal molar mass. The molar mass calculated from the colligative property may be different due to the association and dissociations which are taking place. To rectify it, we add the Van 't Hoff factor I, so modify the formula accordingly. We move on to the next chapter, electrochemistry. In electrochemistry, you should know that there is movement of electrons from the more reactive element to the less reactive element. Do learn the word LOAN, which stands for left-hand side, oxidation, anode, and it is the negative electrode. Reversibility of a cell. When external voltage is greater than E0 cell, the reverse reaction will be taking place. The electrode potential of a cell can be measured by a standard hydrogen electrode, which is used to calculate the electrode potential of various elements. This is used to calculate the electrode potential or the cell potential of the cell by the formula E cathode minus E anode. For calculating the electrode potential of a cell at different concentrations, we use the Nernst equation. Do write the half equations to find the value of N and to know which is the product and the reactant ion. The Nernst equation can also be used to calculate the equilibrium constant Kc and also the Gibbs free energy delta G naught is equal to minus NF E naught cell. For conductance, do be familiar with the formulas of conductance, specific conductance and molar conductivity. Be familiar with the definitions of conductivity, specific conductivity and molar conductivity. Also learn the formulas along with the units. Molar conductivity, the graph for weak and strong electrolyte is important. For weak electrolyte, you can see a sharp increase in the molar conductivity towards infinite dilution because of the complete dissociation of ions. While for strong electrolyte, there is a slight increase only due to the interionic attractions which is decreasing. Colroche law is applicable to calculate the limiting molar conductivity of weak electrolytes. We have the electrolytic cell, different from the electrochemical cell. Electrolytic cell uses electricity to bring about a chemical reaction. In this, the cathode is the negative electrode and anode is the positive electrode. According to the reactions which are taking place, we have two Faraday's laws of electrolysis. The first law, it states that the mass of the substance deposited at the electrode is directly proportional to the quantity of current which is passing through it. Do convert the time in seconds. Second law of electrolysis, use the formula W1 over W2 is equal to E1 over E2, product of electrolysis. Depending on the electrode which we are using, we'll get different products of electrolysis. If we are using an inert electrode, as shown in the slide, electrolysis of aqueous sodium chloride, we get hydrogen at the cathode and chlorine at the anode. Oxygen is not produced due to overpotential. If we are using an active electrode, the metal will be deposited at the cathode and the metal will dissolve at the anode. We have three main types of batteries. Primary cell, we have the example as dry cell and mercury cell, which is used in watches. Secondary cell, the cells which can be recharged. We have the lead storage battery, which is used in vehicles and in inverters. Then we also have the nickel cadmium battery. The last one is the fuel cell, hydrogen oxygen fuel cell. It is more efficient as the electricity can be continuously produced as long as the fuels are being supplied. We move on to the next chapter, chemical kinetics. The rate of reaction is given by the decrease in concentration of the reactant or the increase in concentration of the product. Do note that the stoichiometric coefficient should be written as 1 by the number. The rate of reaction can also be expressed in the form of rate law. Rate is equal to K, concentration of A raised to X, concentration of B raised to Y, where K is the rate constant, X plus Y gives the order of the reaction. Do learn the various units for the rate constant depending on the order. Then next we have the integrated rate equation. For zero order reaction, the rate of reaction is independent of the concentration. Do learn the formula to calculate K, the graphs which are related to the integrated rate equation and half-life as shown in the slide. T half is directly proportional to the initial concentration. Integrated rate equation for the first order reaction, the rate of reaction depends on the concentration of one of the reactant only. Do learn both the graphs and the equation. Half-life is independent of the concentration. Along with the graph, please learn how to work out the numericals. The effect of temperature on the rate of chemical equation is given by Arrhenius equation. Do learn the graph. The slope gives the value of minus EA over R. A catalyst is used to speed up the reaction. A catalyst can lower the activation energy but does not alter the Gibbs energy or the equilibrium constant. Be familiar with the graph. Next, we have the D and F block element with some characteristics of D block element. They are generally metals and solid state except for mercury, which is a liquid. They have variable valency because of the involvement of Ns and N-1 d orbital for bonding. They form colored compound due to DD transition. They generally act as a catalyst because they have variable oxidation state. They form alloy because of the similarity in size. They form complex compounds due to the availability of d orbitals, and they also form interstitial compounds. Do learn the reasons for the various properties. Next, we have the preparation and properties of potassium dichromate, structure of chromate and dichromate ore. Potassium permanganate, also do learn the preparation, the two different methods of preparation and the structure of manganate and permanganate ion as shown in the slide. Lanthanoids and actinoids, they constitute the F block element where the F subshell is being filled. Next, we have the lanthanoids and actinoids which constitute the F block element. Do learn about lanthanoid contraction, the cause and consequence of it. The mesh metal which is an alloy of lanthanoids, do learn its composition. Next, we have the coordination compound. Be familiar with the term central metal, the ligands, the coordination number. When you're naming the compound, first we write the name of the cation followed by the anions. When we have a complex compound, the name of the ligand is written first in alphabetical order followed by the metal and its oxidation number. Do practice the questions of naming of the compound. Structural isomers, it is of 4 type. Ionization isomer, depending on the ions which are formed. Linkage isomer, in case of ambidentate ligand, we have it. Coordination isomers and solvate isomers. Do learn with the examples. The valence bond theory, which helps us to know the shape of the molecule and the magnetic nature. If the coordination number is 4, it is sp3 or dsp2 hybridization. Shape is tetrahedral or square planar. If the coordination number is 6, the hybridization is D2sp3 or sp3d2 and the shape will be octahedral. If the coordination number is 6, the hybridization can be D2sp3 or sp3d2 and the shape will be octahedral. Crystal field theory, for octahedral complex, the T2G set will be having a lower energy compared to the EG set because the ligands are approaching through the axis. For tetrahedral complex, we have the EG set will be at a lower energy level compared to T2G. You should know how to write the electronic configuration if the crystal field splitting energy is greater than the pairing energy and vice versa. The last topic we have is the metal carbonyl. They are very stable compounds due to the synergic bonding which takes place between the metal and the carbonyl group. It has both sigma and pi bond, which gives it extra stability. Do learn the structures of the metal carbonyls. So these were the main topics of physical and inorganic chemistry. Do study well and best wishes for your exam.
Hello students, welcome to the world of organic chemistry. Let's start with the important types of questions that you can expect from the second volume textbook. The first one is nomenclature. Definitely one question about name or write the IUPAC name of the organic compound will definitely come for the examination. Then we have name reactions, direct questions you can expect. Sometimes it will be included in the organic conversions. Then we have assertion reason type questions. We have predict the product type of question, complete the following reactions. We have word problems. Word problem means a compound A reacts with a particular reagent and form B, and B reacts with something and form C. Identify A, B, C, D and write all the relevant equations. Then you can expect increasing and decreasing order of certain parameters which is indicated in the question. Let us start with the first chapter, haloalkanes and haloarenes. Some important naming reactions are Finkelstein reaction, Schwarz reaction, Sandmeyer's reaction, Wood's reaction, Fittig reaction, Woods-Fittig reaction, and Friedel-Crafts alkylation and acylation. You can see a consolidated form of all these reactions on the screen. Next, we move to the important reactions of haloalkanes. The first one, nucleophilic substitution reactions. As you know, a nucleophile will come and replace the halogens in the nucleophilic substitution reactions. Certain examples are on the screen. Now, we have two types of nucleophilic substitution reactions, SN1 and SN2 reactions. The important differences are here. Then another important point is nucleophilic substitution reactions are happening in SN1 and SN2 reaction, but you should know what is the reactivity order. That is very, very important. One question you can expect from the reactivity order towards SN1 and SN2 reaction. Then another important one, ambident nucleophile. A nucleophile which has two nucleophilic centers. Examples are CN minus, NO2 minus, SCN minus, etc. Where the nucleophile can bond with the carbon of the alkyl group through different nucleophilic sites. Next, we move on to the elimination reaction. In elimination reaction, the reagent, please remember, that is alcoholic KOH. When you use alcoholic KOH, elimination reaction takes place. But if you use aqueous KOH, substitution reaction takes place. The elimination reaction is also known as beta elimination because in dehydrohalogenation, the hydrogen is removed from the beta carbon. Now, let's see what happens during an elimination reaction. The alkyl halides reacts with alcoholic KOH and form alkenes. Next one is reactions with metals. That two of them we already discussed. That is Wood's reaction, Fittig reaction, and Woods-Fittig reaction. And another important one is preparation of Grignard reagent. Now we move to the next topic, that is reactions of haloarenes. In reactions of haloarenes, we have two types, nucleophilic substitution reaction and electrophilic substitution reaction. During nucleophilic substitution reaction, the nucleophile will come and replace the halogen. But this reaction is very, very slow because of certain reasons. And those reasons are very important. The first one is due to resonance. There is a partial double bond character between the CX bond. So, as you know, double bonds are quite difficult to break. Second one, in haloarenes, the halogen is attached to the carbon of the benzene ring and that carbon is sp2 hybridized. So, the bond length will be shorter. Shorter the bond length, stronger will be the bond and difficult to break. The next one, the instability of phenyl carbocation, and the last one, there will be a repulsion experienced by the nucleophile from the electron-rich benzene ring. Next one is electrophilic substitution reaction. During resonance, the negative charges are going to be accumulated on the ortho and para positions. So definitely the electrophile will come and attack the ortho and para positions and you will get two products. One is ortho substituted, the other one will be para substituted product. The important electrophilic substitution reactions are halogenation, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation, etc. Moving to the second chapter, alcohols, phenols and ethers. The first one is preparation techniques. The first one is from alkanes by acid catalyzed hydration. Its mechanism is very, very important. You can expect either for 2 marks or for 3 marks this question. Then the next one is hydroboration oxidation. And the third one is from carbonyl compounds. From aldehydes and ketones, by reduction, we can prepare alcohols. Aldehydes gives primary alcohol and ketone will give secondary alcohol. Then from carboxylic acid esters also we can prepare alcohols, especially primary alcohols. And the last one, that is from Grignard reagent. Very important reactions of Grignard reagent. One is this one. That is Grignard reagent reacts with methanol followed by hydrolysis gives primary alcohol. Grignard reagent reacts with any other aldehyde followed by hydrolysis gives secondary alcohol. Grignard reagent reacts with ketones followed by hydrolysis gives you tertiary alcohol. Next is preparation of phenol. There are 4 methods. The most important method and the commercial preparation of phenol is from cumene. That's very, very important. 2 preparations are generally asked. One is preparation of aspirin and this is preparation of phenol from cumene. So aspirin, which is coming in the next chapter, aldehydes, ketones and carboxylic acid, that is also very, very important. I just mentioning that in this chapter. Then the next one, that is from benzene diazonium chloride. Benzene diazonium chloride, just heat with water, you will get phenol. Then by Dow's process. What is Dow's process? That is from chlorobenzene, you can prepare phenol with the help of sodium hydroxide. And the reaction conditions are quite vigorous, 623 Kelvin and 300 atm pressure, followed by acidification. The important name reactions from this chapter are, first one, Colt's reaction, second one, Raymer-Tayman reaction, third one, Williamson synthesis. In Colt's reaction, phenol is converted to salicylic acid. In Raymer-Tayman reaction, phenol is converted to salicylaldehyde, and in Williamson synthesis, we prepare ether. Generally, symmetrical or unsymmetrical ethers can be prepared through this method. The other important reactions of phenol are, first one, electrophilic substitution reaction, second one, the reaction with zinc test. Esterification is also another important type of reactions of alcohols and phenols. Both alcohols and phenols will undergo esterification reaction. Dehydration of alcohol to alkene at 443 Kelvin using concentrated sulfuric acid is a very important reaction. You can expect the mechanism also from this topic. Next topic is ethers, and first one is preparation of ethers. For preparation of ethers, we have two methods. One is dehydration of alcohol at 413 Kelvin using concentrated sulfuric acid. Its mechanism is another important one. Please learn that. The second one, Williamson synthesis, we already discussed that. Here are some important reactions of ethers. The first one is electrophilic substitution reaction. Second one is reaction of ethers with HI. In every year, there will be one question regarding reaction of ethers with HI. Move on to the third chapter, aldehyde, ketones and carboxylic acid. The first one, Rosenmund reduction. Second one, Stephens reaction, Etard's reaction. Then we have Gartermann-Koch reaction, Clemenson and Wolff-Kishner reductions. Then we have aldol condensation, cross-aldol condensation, Cannizzaro reaction, and finally haloform reactions. Other important reactions of aldehydes and ketones are: first one, reaction with ammonia and its derivatives. Second one, reaction with HCN, that is hydrogen cyanide. The product will be respective cyanohydrin. Then reaction with alcohol, acetal or ketal you will get as a product. Then reaction with sodium bisulfite. The product will be respective sodium bisulfite adduct. And reactivity, if we check, you can see that aldehydes are more reactive than ketones. Next topic is carboxylic acid. Preparation of carboxylic acid from alcohol, from primary alcohol, is very important. Then hydrolysis of amides, nitriles, acid chlorides, acid anhydrides, these all will give you the carboxylic acid. When come to the important reactions of carboxylic acid, one naming reaction, that is the only one naming reaction from carboxylic acid, very important, which is HVZ reaction. The next topic is acidity of carboxylic acid. Acidity of carboxylic acid will increase if there is an electron withdrawing group present, and it will decrease if there is an electron donating group is present. Next, the fourth chapter, that is amines. When we check the preparation of amines, the first one is preparation of amines from nitro compounds. For that, the best reagent is Fe plus HCl. Please learn the reason for that. The next one is reduction of amides and nitriles, then ammonolysis of alkyl halides, then two name reactions. First one is Hofmann-bromamide reaction or Hofmann-bromamide degradation reaction, and the next one is Gabriel-thalamide synthesis. The next one is reaction with nitrous acid. That is again very important because you can convert amine to an alcohol through this reaction. The next important topic is diazotization and reactions of benzene diazonium chloride. You know, diazotization means aniline reacts with NaNO2 and HCl under ice cold condition, gives benzene diazonium halide. These benzene diazonium halides are very important reagent because we can prepare so many compounds from benzene diazonium halide, as you see on the screen. Now, next we are going to discuss about some important chemical tests. The first one is Lucas test. Lucas test is used for distinguishing primary, secondary and tertiary alcohol. Primary alcohol, no turbidity. Secondary alcohol, turbidity after 5 to 10 minutes. And tertiary alcohol gives turbidity immediately. Lucas reagent is concentrated HCl and anhydrous ZnCl2 mixture. So if you use this, you can identify which one is primary, which one is secondary, and which one is the tertiary alcohol. The next test is neutral FeCl3 test. This is used for identifying phenols. Phenols gives violet coloration with neutral ferric chloride. The next test is bromine water test. Phenol as well as aniline gives you bromine water test, and the product or the observation will be a white precipitate. In the case of phenol, the product will be 2,4,6 tribromophenol, and in the case of aniline, 2,4,6 tribromoaniline. In both the cases, the precipitate's color will be white. Next one, tolerance test. Tolerance reagent is ammoniacal silver nitrate solution. This is used for distinguishing aldehydes from ketones. Aldehydes gives positive test and the result will be a silver mirror. The next test is Felling's test. We have two solutions, Felling A and Felling B. When we take equimolar mixture of this and reacts with aliphatic aldehydes, it can give you reddish brown precipitate. But If you use aromatic aldehydes or ketones, the result will be negative. Then we have iodoform test. In iodoform test, the reagent is iodine in NaOH, methyl ketones, ethanol, and secondary alcohols with a CH3 group adjacent to the secondary alcoholic group can also give you iodoform test, and the result will be yellow crystals of iodoform. Then coming to the next test, which is carbylamine test, that is answered by only primary amine. When heated with chloroform and alcoholic KOH, we will get an offensive smell of carbylamine. Then azodite test, which is used to distinguish phenol from aniline. Phenol in alkaline medium reacts with benzene diazonium chloride, gives an orange dye, and aniline will give a yellow dye. The next one is test for amines to distinguish primary, secondary, and tertiary amines. That is Hinsberg's test. Hinsberg's reagent is benzene sulfonyl chloride. When primary amines react with benzene sulfonyl chloride, we will get an alkali soluble compound. Secondary amine will give an alkali insoluble compound, and tertiary amine does not react with benzene sulfonyl chloride. And the last important test is sodium bicarbonate test. This is the test to distinguish carboxylic acid from other functional group. Carboxylic acid gives brisk effervescence. The first topic is carbohydrates. In carbohydrates, first one is classification. We have classification based on the product of hydrolysis. First one is monosaccharide, then disaccharide, then polysaccharides. Monosaccharide we cannot hydrolyze into simpler units. For example, glucose and fructose are examples for monosaccharides. Then we have disaccharides. Disaccharides upon hydrolysis gives two monosaccharides. Example, we have sucrose, maltose, lactose, etc. Then we have polysaccharides. Polysaccharides gives many units of monosaccharides upon hydrolysis. Example, starch, glycogen, etc. The difference between amylose and amylopectin, which are the two components of starch, is very, very important. Study the difference between them. The next topic is amino acids. We have two types of amino acids, essential amino acid and non-essential amino acids. So essential amino acids we have to take through diet, and non-essential amino acids our body can synthesize. Then the next topic is Sweeter ion, very important one. Then the structures of protein, primary, secondary, tertiary, and quaternary structures of protein, very important. We have two types of proteins based on the shape. One is called globular protein and the other one is fibrous protein. Globular protein example is insulin, and fibrous protein is keratin. The next topic is peptide linkage. Peptide linkage is the amide linkage which connects two amino acids together in a polypeptide chain. Like this only the proteins are formed. The next topic is vitamins. There are two types of vitamins, water-soluble vitamins and water-insoluble vitamins, or we can say fat-soluble vitamins. Fat-soluble vitamins examples are vitamin A, D, E, and K, and the water-soluble vitamins are B and C. So water-soluble vitamins we have to include in our daily diet because they are water-soluble, so it will be excreted through urine. Then we have deficiency diseases of different vitamins. There is a table in your textbook that you must learn. Then about nucleic acids. There are two types of nucleic acids, DNA and RNA. The difference between DNA and RNA are very, very important. Two strands of DNA are complementary to each other. Then two important terms, nucleoside and nucleotide. Nucleoside and nucleotide difference you must learn. And the functions of RNA and DNA is another important topic. These are the important topics from the second volume reader. Now, when you present your answers, there are certain things you have to take care. That is, first one, when you have distinguished between or differentiate between type of question, present your answer in a tabular form. Then all the calculations should be in the right hand side, that is in the working column provided. General guidelines, make sure that you have attempted all the questions. Then check the question numbers, the subdivisions, etc. Cross the unused part of your paper with your answer sheet with pen, that too diagonally you have to cross. That's from our side. All the very best from Indian Community School, Kuwait. Thank you.